Hi, my friends. Welcome to my second part. So, for the logical equivalence, in this lesson, we will proceed equivalent compound booleans, which is subtopics of the logical equivalence. It will be part two. So, before start this lesson, please watch equivalent logical equivalence part one, and then come back here. So, let's start it. Many logical expressions use a mix of not and or. This is logic gates, right? We know that. So, how compound logical expressions can seem complicated. There are some useful logical equivalence rules that can help. We are going to consider two rules that were known by Greek and medieval logicians. However, they were named for the logician Augustus de Morgan. So this is the Morgan laws. You learn all of them, all right? So who wrote them down in the 1800s, double zeros, like 1800s. So they are commonly called the Morgan's laws. Okay, let's look for the first rule. All right. Let's start with a real world example. The countries of Egypt and Sudan claim different areas of land as part of their country. A very unique aspect of this particular border is that there is actually an area of land that neither Egypt nor Sudan claims. So this arises because the area is an inhabited part of the Sahara Desert, and more importantly, accepting that area of land would mean giving up a larger and inhabited area of land that both countries claim. A picture of the area is below, right? Let's check it. Okay, this is, like you can see here, yellow part, land claimed by Egypt, yellow in here, so okay, and Sudan is blue. Sudan is here, and Egypt is here, all right? So, what we are going to do here, we need to understand this white point and these two country not claiming to get this place in Sahara. I mean, this is forest, like crazy points. So neither white. All right, both like claiming about green, but not about white. So let's come down, see what will happen in here. All right, all right, where is it? Oh, what's happened? So 1 minute, just let me go back to there. It will be here. All right, we just already see this picture. We can describe that area of land in English. The desert area is not claimed by Egypt and also not claimed by Sudan. So both of them thinking same, like you're not climbing it. Okay, that's logically equivalent to this statement. The desert area is not claimed by Egypt or Sudan. All right, we will make it programmatically true. All right, let's continue. Let's come back to the, slide it down. Yeah, hopefully, reading both statements makes it clear that they describe the same thing. If not, read the sentences again and think about why they are the same. It may also be helpful to look at the map again. On the map, the statements describe the area in white, signifying that neither country claims the land, right? Now translating the original English sentence into pseudocode. Yeah, not, and after that, claimed by Egypt, and not claimed by Sudan. So, what if we apply our De Morgan's laws or in math point? So let's say we will put here one more not. It will be like minus negative, right? We're making negation. It will be plus, right? So we can say plus for here. Let's say like that. And let's apply not also in here, not and will be or in this point, right? Or, so, and after that, not climate. Let's apply again not to here. It will be again like to negative will make as positive. So what we can say now, we can say not climate by Egypt or yeah, climate by Sudan. Did you see what we catch here? So the condition is same, not climate by Egypt or climate by Sudan. They are doing same stuff, right? So I hope you understood this point. It is same in here. So the general form of this logical equivalence rule is not A and not B. Like it is same like if we delete this two, it will be just one not, right? It will be same. We can apply for this and for another, not A or not B. So if we put here also not and will make it or, not and equals to or, not or equals to and, right? We know that. All right. Keep in mind that the equivalence holds in both directions. That means if you see the conditions, not A or B, you can change it not A and not B. So, right. Let's apply not and for here. It will make it or. It will be not A or B. Same. I hope you got it. Right? This is very easy and it will have the same meaning. Check your understanding. Check your understanding, really. Let's do together. Consider this Boolean expression about the categorization of rice. So, not food type equals the fruit, okay? And not food type vegetable. So, let's put here again one not. And let's put before and also one more not. And put for here another not. So now calculate it. So it is logic. Not will make one not. All right. Let's say plus in here. So food type fruit and not and will make or. Yeah. Not and will be or in here. We are talking about. All right. Let's do it better than before. Okay, not and will make or, and not will make again plus. So what we can say not food type, like not food type, let's say food type for that equals fruit or, yeah, let's say this is F fruit for represent fruit or food type, food type vegetable. Yes, it is just that. So let's see in the options which of the following expressions is logically equivalent. Alright, let's see which one. So let's come here. Alright, not food type fruit or food type vegetable. Do you think it's true what we did here? Did you see? Not food type fruit or food type vegetable. Not food type equals fruit or not. No. Food type equals fruit and not. No. Not food type fruit or not or. If we apply here not, okay, it will be like, okay, food type not equals to fruit. But if we do it in here, not or will do it and it will be not food type equals fruit and uh, the food type vegetable, not food type vegetable, which means it will make both of them have to be true, okay? And it is not true. The A is the true one, all right? This one, it is true. So maybe we can do it programmatically. Let's let's do it together. All right. So we have two variable food type. So one variable food type and different foods. Okay. What we can do? Let's come here and go first for the here. And all right, let's come back to here. So what we can say? We can say we have food type here, fruit, and food type vegetable. We can say first, all right, let's come back. We can say for the variables, just I'm thinking what variable we can put there. So yeah, let's say food type equals to what? Equals to what? Let's say pizza, right? Something else. And let's come down and say if, as we are in JavaScript, let's do it like that. This one will make it not. All right. After that, let's say food type equals to, or we can do it like strict equals. Yeah, let's write through it and make it end also there. We can do it and so sorry, or food type equals what? Vegetable. Yeah, you can say in here text this is so if not them it have to show us our variable, but let's do it in here. Food type count is enter food type. Okay, maybe we can say sorry, we can say here user choose and come here. This is and this is this is not fruit. Then we can say what? What do you think? This is not fruit or table. Do you think it will work there? Let's say display and let's apply. Let's go up and put here ID. Let's say food. Come back down and come inside here and say food. And all right, put text there and console.log log and put inside display in here and put here var, put here var. Okay, Let's go to the page. What will happen? And put here else. All right. Else word text. Text one. Let's say text one. This is widget table and fruit. Let's say like that, okay? After that, just copy this, come back to here and say word display one and word display one, and text one will be text one, right? So now in here, we can say if, let's change it because I can do user choose two. If user choose, let's put for here too. Let's see what will happen. All right, let's apply in the program. See what will happen. All right, let's say vegetable. This is vegetable and fruit. Because why? I just put here this one. But which one worked? Did you see? I wrote vegetable and here worked. Else conditions work. Because we have here not. They not have to be equals to fruit or vegetable in this case. Because look our examples saying not to five like food type have to be like has to be fruit or has to be vegetable, right? All of them have to be different things. So in here if we say other things, let's think another things. Okay, let's say pizza. This not fruit or vegetable. Did you see how it works? Perfect. This is not fruit or vegetable. You said this is pizza. It said this is not fruit or vegetable. But when you say like fruit, let's say fruit, it will say this is vegetable and fruit. What do you think? When we make something true, like for here without not, this condition's working, like in else station, all right? So not making else and else come in here like if, like true statements. But we are looking here exactly for what? We are just trying to understand not and. So in here we have not food type. For not food type, everything is going here like that. Look, not food type, food type equals fruit and we have and, right? Let's back and do it. And not food type, food type equals vegetable. All right, we just applying here that. Look, not, one more not, okay? And for here, we have another not. We adding to here and next to end. And one more in here, we adding again. And yes, not, and here not. They will be just one not, like that, not. After that, we have not and here. It's exactly equals to or. All right, and we have or between them, and just we need to put their food type, yeah, equals fruit, or food type equals to vegetable. Exactly that. Did you understand what I did? So if you apply again not here, it will go back to same situation. Okay? So if you put here now not, okay, open it and apply for here one more not and put here again not, what will happen? What do you think? Not for here, not for here, and not for here. Let's say not. Let's see what will happen now. Not will be one not, right? So in here, so this one and this one plus one not. And we have not or in here because it is exactly equals to and, and we can say here we have and between them. We can say food type equals to fruit and, right, food type equals to vegetable. What happened right now? Did you see what we are doing? All things change, guys. Alright, what I did. Let me solve here. So something is wrong right here. Alright. Okay. Now can you see the point? If you apply again not and will make it or again, but in here both conditions have to be true, right? But in here one of them have to be true. So alright. If we say not and, it will be or, not or will be and. So it's always going in this way. Okay? I hope you got it. So let's go up, guys, in here and do same things in Python. I would like to show you in Python too. So just I'm trying to explain you how these things work, okay? Let's say food type equals to input. Please enter food type. Right, food type. And let's come here and say if not, put here that. After that, say food type equals to fruit, right? Fruit or food type equals to vegetable. Do something else. Do what? Let's say text. This is not fruit or vegetable. Okay? So, and say else. Next one. This is fruit and vegetable. Let's do it like that. Okay, just I'm trying to show you something to understand it, okay? Say print. I just want to explain you how to make and or not, like not and to or not or to end, okay? Just I would like to do it. Or because I know you already learned how to apply these things. If not, if we put here one more not. So in here, if we put one more not, so and for here one more not or will make it and if you put here not again, so everything will be clear. So not will be plus and not or will be and. So we can say not food type equals fruit and food type equals vegetable. So it's all will continue like that. But let's do first example how it works. So let's do it. Let's run program and see what will happen in Python. All right. So now you can see what will happen. All right. Please enter food type. What if I say fruit? This is fruit and vegetable. Else conditions work because we have here not, right? What if we say and? What do you think what will happen? Let's say fruit. This is not fruit or vegetable. What's happened right now, guys? Just think about it, okay? So, by the way, what is so? 1 minute, right? Okay. So what's happened when I do it? Like, or what's happening when I do it? When I write here fruit, saying this is fruit and a vegetable. But when I say and, it's going different things. Why, guys? Why it's work like that? Fruit. Bam. This is not fruit or vegetable. So here not verbs. Here verbs. When I put there fruit, it's saying this is not fruit or vegetable. Because why? We saying food type and food type are the same variable. If we are saying if like fruit is true, then do it. But if we apply here or because we have one variable in here, guys, all right? We don't have two variables, we have one variable. All right. If not, like let's think if food type not equals to fruit and not equals to vegetable, do this. This is not fruit or vegetable. If food type not equals to fruit or vegetable, so if food type equals to fruit or the vegetable, do this one. All right, but we need to use here or because this is one variable. All right, I hope you got it. So just not and equals or not or equals and. Right? Is that? It works like that, guys. So let's go back to the first point. All right. So we can continue from here. We already made it. Rule 2. So we have rule 3 to, yeah. To understand a similar rule, let's look at the unique road tunnel in the marine headlands. An area near San Francisco, California, this tunnel is only wide enough to support vehicle travel in a single direction at a time. So both cars can't go in here together, all right? Just only a car has to go there. So the narrow tunnel is wide enough for a single vehicle. Due to this constraint, the tunnel is nicknamed the 5-minute tunnel, since it has traffic lights at either end that allow traffic only in one direction for 5-minute intervals. All right, this is plays our tunnel, 5 minutes tunnel. What's the logical rule that will keep this tunnel safe to prevent collisions? We need to ensure The traffic in each direction cannot travel at the same time. This could be stated as the tunnel is not used at the same time by eastbound traffic and westbound traffic. So just we can do it like that. Not eastbound traffic and westbound traffic. They can't do it together. This is logically equivalent to what? Not eastbound traffic. Or because if we say not and, if we apply here not, and if we apply here not, if we apply here one not more, it will be what? So for here too, not and. So not will be plus point, not and will be or, not westbound traffic will be not equals to westbound traffic. So not eastbound traffic or not westbound traffic. Did you see what happened? It happened or. The second pseudocode condition might feel harder to parse than the first, but it makes more sense when you think about the rules of the tunnel in another way, in list of one direction. So there is no traffic using the tunnel. Either there is no traffic going east, not eastbound traffic, or no traffic going other direction, not westbound traffic. So both conditions describe the rules of the tunnel equally well since they are logically equivalent. The general form of this rule is what? So not eastbound and not westbound. It means that not eastbound and not and will be or, and we will put another not here too, not westbound. Not eastbound or not westbound. It is same guys, not a, we will put another not here, and not and will be or, and not b will be like that here. All right? I hope you understand. Not and equals to or. Guys, breaking down the rules. In math, there are many ways to think about this rule. One is considering it similar to the distributive property from algebra. When we have something like minus time minus will be plus. Minus time plus will be minus. Minus time minus will be plus. What's happened? X minus y. Yeah, is the same as I did this one. And if we do it here, like if we open this topic, minus minus will be plus, minus plus here. What will be plus minus? All right. And after that, minus time minus will be plus, and if we apply here minus time plus, it will be y. So it's saying which is the result of this ring, the sign, each sign and operation. So distributing the negative changes the sign of the numbers and changes the addition between the numbers to subtraction, although not entirely the same. Similar reasoning can help you remember these rules for these conditions. Not A and not B. Not and will be or, not A or B. So it is same that. It's like distributing to not to A and then not to end. And then A becomes not A, B becomes not B, and becomes or. I show you. Not and will make it or. Not A, not and, it is or. Alright? Not A, not and or not B. Not A or not B. So not A or B, it is same. Not A or not B. Not A, not or will be and, not B, like two times if we apply it, it will be B. It will say not and like that, not A and B. Okay? The same. I hope you get it. The distribution approach also works for the first rule mentioned. Start with not A or B, distributing normally, if you put here not, not or, not be, not or will make it and, right? Let's think it and not B. So it will be not A and not B. So it will be not A and B. It is same negation with or, not and will be or, not A or B. Equivalence between conditionals and booleans. This is our another subtopic. Let's continue with it after some minute. Yes, friend. Equivalence between conditionals and booleans. It's important to understand logical equivalence when writing computer programs so that your program's behavior is both logically correct and understandable by other programmers. There are many ways to write code that is logically equivalent, but there is often one way that is clearer and more concise than the others. Let's look at some logical flaws in pseudocode that can be simplified using the logical equivalence rules and alternative programming structures. Let's see structural equivalence. All right, first let's consider an example where we are trying to set a variable which reports if something is frequently used. We might write code like this. If numbers like number users greater than 100 is frequently used, like applications, let's say it is true, else is frequently used false, right? That's not true. So, this seems like perfectly reasonable and clear cut. However, the astute observer will note that only operation done each block of the if else is setting the value of is frequently used. So it sets that value to true if number users greater than 100 is true, false in the else case where number users greater than 100 it's false. Have to like has to be less than 100, right? So we can replace the entire if else block with a single line of code. Yeah, we can do it. Is frequently used if number of users greater than 100. This will check number users like greater 100, produce a boolean true or false, and then assign the value directly to the variable is frequently used. To generalize this rule, if there is an if else of this form, let's see like that. If a word is e, v have to be true. Else, like let's say C, it will be false. This statement is logically like V have to be E, right? In this case. So that's true exactly. So structural equivalence with negation. All right. Consider the code below that does a similar but opposite operation reporting if something is rarely used. So if number users greater than 100, in this case we are looking for the false conditions because is rarely used false because number of users the greater than 100 it is not true is else these conditions have to be true which is it works with it, right? So it is corresponding to that one, right? So it's rarely used true. It's rarely used false. I mean what? So in this case, we did opposite side. So we said is generally used, like in here, is frequently used. We just change it is frequently used variable to is rarely used. In this case, it will be false because it's not rarely used. It is frequently used. But yeah, in this case, if we say it's rarely used true, it will be else like so it is greater than one. Okay, so it is false if situation is like that, else is true if situation in else case. At first, it seems like so. I just want to show you one thing like just we change it here variable we can do it like in 2 points so we can just use our mind to show what is going on. So there we go. At first, it seems like we are stuck because now our code is doing the opposite of the above. It sets the value to false if number users greater than 100 is true, not the same value I told you. So false if number users greater than 100, it's rarely used, is in this case will be false. And else, if you say if not that, then rarely used will be true, right? True otherwise when number users greater than 100 is false. Yeah. Fortunately, we can use the logical equivalence rule from the first article and equivalent on equivalent simple booleans and use not to get the opposite value of a boolean. So, so the above if else the same as the line of code is rarely used. Number users greater than 100. In this case, we will put not if if number users not greater than 100, then it's rarely used. That's true. If number users greater than 100, it's frequently used, right? Just we put here not to do it. In general, our rule is this. So let me show you one thing. In this case, what we are saying, we are saying if number of users, if let's say num of users, it's greater than 100, let's say, I just showing you example, okay? Console.log, mm, so okay, let's do it frequently. It's frequently is frequently used. Let's say true in this case, or true, right? Else is frequently used false. For false, right? So what we said here, we said if number of users greater than 100 is frequently used. That's because number of users is greater than 100. And if not, it is not true. So, okay, in this case, let's do if num of users greater than 100, do opposite is rarely used. So then we can say it's rarely used. It will be false, right? Else it's rarely used. So in this case, it's saying it's rarely used. It is false because the number of users greater than 100. In this case, it will be true. If it is like if number of users greater than 100, it's rarely used, it will be false. And if the number of users less than 100 is rarely used, it will be true. In this case, it will work like that. But one more thing in here. So we can do the same thing like that. If not num of users greater than 100. Yeah, if number of users not greater than 100 is rarely used, be true in this case, right? It's rarely used. Else, rarely used will be false because it will be less than 100, right? So greater than 100, yeah, we have not, it makes it to opposite side, all right? So this is same logic we applying for that. I hope you got it. Let's continue. So, in general, our rule is this: if A it's equals false in this case, else be true. So if someone enter there E, it will be false. V will be false. V equal false. If some people wrote there F, it will be true in this case. If someone enter E, it will be false in this case. So this is opposite meaning, okay? So we can say for that, if not E, if user input not equals to E, it will be what? What do you think? If word is not equals to E, then have to be word another thing. So in this case, if we put here E will be like not E, it has to be another thing. So this is same logic, guys. Just check here. So this point will be in this case true if not E, if E, V will be false. So if not E, F will be true, right? You understand what I mean? It is same logic like I did before. Check your understanding. Consider the code. All right. If age less than 18 is adult, false. All right. Else is adult, true. Right? That's true. Which of the following is logically equivalent? If age less than 18 is adult, true. Else adult is false. Do you think it is true? No. Not true. Is adult age? No. Less than 18? No. That's not true. Is adult age greater than or equals to 18? Do you think it's true? Hmm? Yeah, that's true. Is adult on like 18? But in here, so in here, where is it? If something like not greater than, so not less than 18, if something less than 18, if you put there not, it has to be greater than or equals to 18. So in this case, what we can say is adult 18 will be in this case, because we are here we are saying like 17 and others. Okay, in this case it will be also true. All right, is adult true. So let's continue, guys. Combining equivalence rules. Now that we have a firm grasp of many logical equivalence rules, we can use them together to yield some interesting results, combining with not not. Let's see. With not not. Recall that not A. So if it is not A, it has to be B, right? Let's say B. Or D. Not D will be again E. So it is same, guys. It's equals equivalent to A again. Because if not A, it will be D. If not D, it will be E again, like A. So let's look here. Not is moving, not is alive. Let's do apply for all of them. Let's put here not. If not will make positive, like negative negative, like in distributing math, okay? Multiplication. Not will make it only is moving, right? Is moving. And not and will make it or, like in here we distributing not will make it or, right? And if we put another not front of it, it will be not again, is alive, let's say like that. And it will be is moving, so is moving. And after that, See what will happen. Applying the Morgan's laws, that's equivalent to not is moving or not, yeah, or not and. Did you see here? We have one not here, and if we put in here, not is moving or is alive. Okay, so in here, not is moving or not, it will be and again, and it will be and not not will be plus, like plus is moving. I mean, just think it's moving, all right? It's positive now. If you apply like not to here, not to here, and not to here, let's say another not in here and one not also here, it will be is moving. Now or not will be and, not and will be again or, like before. Not will be is alive. Plus is alive. So it's alive. Okay. So did you see or not has to be have to be and not and have to be or. Again, it's change. And that can be simplified all the way to I told you is mowing or is alive. So what we did, it is true way. So what we did in process C first, we said not is moving and we distributed inside it step by step. And on out it's happened is moving, not and made or, not is moving or not is alive. Like so not is moving and is alive. So and after that we said we have here or right now. So if we apply same not to inside it, not will be is mowing, like plus mowing, because the two negative will make positive if we multiply them, right? It will be positive. And for here, same situation, and it's happen is mowing, and or not will be and not and will be or. And after that is alive combining with not equals. Another rule is that not equals is equivalent to that one. You know that in math, right? Consider this expression, not my age. So in this case, we can say my age is not equals cousin age, and my age is not equals to friend age. So let's say not, let's put here not, and not and will be or, right? And for here, do same things. What will happen? Or not will be and. It is equals to that. That's writing. We can write it like that. Not my age equals to cousin's age. Or not will be and, which is or not. Not or will be and, or not will be and. Same. In here, it's equals to here. Or not equals to and. My age is friend age. So we can say not my age is equals to cousin age or so and my age is friend age. So which is we can say it like that. My age is not equals to cousin's age. Now here we have and not and. If we apply here and here and here, what will be? It will be not equals. This one will come here. It will make it not equals. And this one also will come here. It will make it not equals. And this one will go there. Not and will be or. So let's see below these things. My age is not equals to cousin's age or not and or my age is not equals, which is it made it like not equals friend's age. Did you see? We just made clarification. That's all, guys. Check your understanding. Not just no or not or and will be like or not. And not will be or, not and will be or, not or will be and, or not will be and. Okay? Check your understanding. Let's check it. Consider this the pseudo code. Not light on and not door closed. Let's put into this point. Let's distribute this into them. So onto them. Not put here one not. It will be not light on. Put not and next to it. And put another not into here. Right. So what's happened now? Light not will make plus. So the light will be on. So we are saying here not light on in parentheses, not light on because we distributed not to inside all. So not light on, not so light will be off, right? And after that, not light off, it will be light on again. So not will make plus. I mean minus will be plus. And not and will be or. Am I right? Not and will be or, and not or will be again and. All right? Look, light on, we distributed inside it. I just distributed like that, right? You know that. So we have also here one not. Not will be plus, not will be plus. So not light on, has to be off, light off. And not light off, it will be light on again. If we say here not and, it will be or. And not or will be again and. Not door closed, door will be open. Not door will be open, door will be closed. Did you understand? Light on and door closed. It will be like that. So let's see. Do we have this option in here? So light on is logically equivalent, not light off. Door closed is logically equivalent to not door open it. So light on or door closed. This is true. This wrong, wrong, and wrong. Oh, sorry, not true. I'm just sorry. I made it wrong. So in here, our true light on is not light on will make it light off. Not and will be or in this case. Okay. So we're just putting in here. Not and will be or. Not light on. It will be light off. I'm sorry. Light off. And this is true. Light off. And not and will be or. That's true. And this one. So anyway, this one not true. And not door closed. Door has to be open. Door closed. Not door closed, door open. But can we see the option? Light off and door closed. Just a minute, guys. Hey friends, yeah, just I think I wrote here some wrong codes. So just it will be light off or door closed. Because why? I will show you now. Not light on, it will be light off. Not and will be or. And not will make plus. Like minus will be plus. So plus door closed. Like it will be same. Not door closed. The door is open, not door open. It will be door closed. All right. We just distributed it in all side. Not light on, light off, not and or, not door closed, door open, not door open, door closed. So it is true in here. Then others is false. All right. All together now that we have all these tools, let's work through some examples that use many rules. Example one. Consider the following. All right. So we have not A, it will be B. Let's say B. Not, oh, sorry. A equals B. It's saying not A equals to B, and not, so A not equals to B, and not A not equals to B. It will be A equals to B again. Not or will be and C is the greater than 100. C is the less than 100 if you apply it to here. So let's do it like that. Not A equals to B. Okay, A will be like that. And not, so sorry, not A equals to B. It will be A not equals to B. If it's, let's do it in here. A not equals to B. And if you put like not A equals to B, it will be A not equals to B. And if you put again not here, not equals A equals to B, it will be A equals to B. Okay? Equals to B. Same. And like not or will be and in this case. And A equals to B and not C greater than 100 or and so in this case C has to be less than 100, less than or equals to 100. So yeah, C has to be less than or equals to 100. Okay, it has to be like that. Not A equals to B, not and or, not C greater than 100. It will be less than 100. So let's see, it's equivalent to two knots. In this case, we saw it. A equals to B and C, not C greater than 100. It's also, I did here. It's already there, guys. Look. A equals B and C less than or equals to 100. A equals to B and C less than or equals to 100. Okay? Example 2. Let's see here now. Intro. Sometimes the path to simplifying an expression starts by making the expression longer. This is usually done by adding knots to enable the applying of the Morgan's laws. So the goal is usually to get an expression like not A and not B. So not A will be B, not and will be or, not B will be A. So not B will be B, not B will be, sorry, not B will be A, not A will be B again. So what we can say, not A, not and, not B. Not A will be B. Let's say in this case, not A, we can just separate it like that. Not A will be B, and not and will be or. Not B will be A, not A will be B again. Or B. A or B. It will be A because we'll put here one more not. Not A or B. It will be that. I showed you here. Or not A or B. Example, let's start with the expression. A equals B and C equals D. On the first look, it might not seem like this can be changed and anything, and that can't use the Mergen's laws because there are no knots. So this is good time to try add some knots. Okay, we will put here not A equals to B, and